So we've graphed linear equations, y equals mx plus b, where we plot the point b and then we use the slope m to do rise over run and then to draw a line. This is extremely similar. The only thing that's different is that we're going to be doing some shading because it includes sometimes it's a greater than or equal to, so it's everything that's greater than that, and sometimes it's less than or equal to, so it's everything that's below that. But first we're going to check to see if something is a solution to an inequality. So we substitute the ordered pair into the inequality and evaluate if it results in a true statement, then it is a solution. If it results in a false statement, then it is not a solution. So remember that our ordered pair is x, y. So I'm going to substitute the ordered pair into this equation. So 2 is less than negative 9 times negative 2 plus 7. So 2 is less than negative 9 times negative 2 is going to be 18. So 18 plus 7 is 20 what? 25. And 2 is less than 25. Is that a true statement? Yeah, so this is a solution. Alright, so we're going to do the same thing here. Substitute in my ordered pair. So negative 8 is less than negative 9 times 3 plus 7. Negative 9 times 3 is negative 27. Plus 7 is negative 20. Is negative 8 less than negative 20? No. It's greater than. It's closer to 0, so it's bigger. So this is not a solution. Alright, graphing inequalities. So to get the inequality into the proper form, normally this would be y equals mx plus b, but instead of an equal sign here, we're going to have our inequality signs, which includes greater than or equal to, less than, and less than or equal to. Okay? And then we graph the points on the line, so we're going to use the m and the b. So I'm going to plot my b, which is my y-intercept, and then I'm going to use my slope, m, rise over run, to find additional points. Then we're going to determine the type of line. So remember when we were doing these when we were plotting these on our number line, we would have an open circle for the ones that are not equal to, because it doesn't include that value. So instead of having an open circle, we're going to have something called a dashed line. It looks like this. It means it's not equal to that value, but that's where it stops at. Okay? And then if it has an equal to sign, it's going to be a solid line because it includes that value, just like how our dots are solid when it's equal to, like this. And then we're going to shade the appropriate side of the line. If it's greater than or equal to, we're going to shade above. So, for example, if this was my line, I'm going to shade above the line. Anything that's greater than that value could be a solution. And then if it's less than or equal to, we're going to shade below, because it's any value that is less than that value. It doesn't matter the slope, the direction of the slope, positive or negative, does not affect shading. Alright, so this is a dashed line, so it does not include the equal symbol. So, and it's shaded above, so that means it's going to be greater than. So this is a solid line, so it includes the equal to sign, and it's shaded below, so it's less than. Okay? Here it's a solid line, so it includes that value, so it has an equal sign, and it's shaded above, so it's greater than. Again, solid line, so it includes that value, and it's shaded below, so it's less than. You see how the slope of the line does not change the shading, okay? Vertical lines, though, are one exception with above and below because you can't have above a vertical line. So if it's greater than, you're going to be shading to the right. This is the dashed line. Hard to see. And then if it's less than, which will be shaded to the left, so this one would be x is less than -1. It's a dashed line, so it doesn't include the equal sign. So here I have a solid, but horizontal lines, it's still above and below. So vertical lines are the only one that's like different. Because this is shaded over here, and this one's shaded over there. So here, this is all shaded up here. So this is going to be y is greater than or equal to -4, because that's my equation. Normally this would be just y equals -4. The only part that's different is the greater than or equal to symbol. And then same thing here, except for it's less than, and it's y is less than 2. All right. So we first need to make sure it's in our y and then our inequality sign mx plus b form. So remember, this is where your inequality could go. So this first one is in that form. So I'm going to identify my m, which is -1, and my b, which is 2. So I'm going to graph this like we would normally graph. Starting at my y-intercept, which is 2, and I'm going to do my rise over run. So I'm going to go down 1 and 1 to the right. Down 1, 1 to the right. And keep doing that. Or I could go up 1 and 1 to the left. And then is this going to be a solid line or a dashed line? Solid, because it has the equal to. And then are we going to shade above or below? Above, because it's greater than. You guys can use like your pencil to shade, like actually shade like that, but I don't have a pencil. So this could be any value that is above this line, and including on that line. All right, so let's look at this next one. Is it in my proper form? No. So I'm going to add 2x to both sides. So I'm going to have y is less than 2x minus 1. So now it is, so my m is 2, or 2 over 1, and my b is -1. So I'm going to start at -1, and then I'm going to go up 2 and over 1. Up 2 and over 1. And then is this going to be a solid line or dashed line? Does it have an equal to?
No.
So it's going to be dashed. Because it does not include that value. And then are we shading above or below? Below, because it's less than. Okay, is this in my form y inequality sign mx plus b? No, so I need to get in that sign. Oh wait, so I'm gonna subtract 1/2 x from both sides. So I'm gonna have negative y is greater than negative 1/2 x plus 3. I need to divide by -1. When you divide by a negative number, what happens to your inequality sign? It flipped. So it's gonna become a less than. This is 1/2. This is positive now. 2 negatives, and then this is -3. So now my m is 1/2, and my b is -3. So I'm going to start at -3. I'm going to go up 1 and 2 to the right. Up 1, 2 to the right. Up 1, 2 to the right. All right, is this going to be solid or dashed line? Dash, because it's not equal to. And is it going to be shaded above or below? Below. Because it's less than. Okay, we're going to do the same thing here. I'm going to subtract 2x from both sides. And we get -3y is less than or equal to -2x plus 6, dividing by -3. So I need to reverse my inequality sign. So I'm going to have 2 over 3x minus 2. So my m is 2/3, and my b is -2. Starting at our b, our y-intercept at -2, I'm going to go up 2 and over 3, up 2 and over 3. Is this going to be a solid or dashed line? Solid, because it's equal to. And then am I going to be shading above or below? Above, because it's greater than. Okay, we have y is greater than -1. So is this going to be a solid or a dashed line at -1? Dash, because it doesn't have an equal to. And am I shading above or below? It's greater than, so above. Okay. And when x is a number, then that is a vertical line at that number, so it's going to be at 0. And it's a solid line because it's equal to. And am I going to be shading to the left or to the right? It's less than. So everything that is less than. Oh, well, whatever. One more problem. All right. So you want to spend no more than $15 on fruit this week. So that means I'm going to be spending less than or equal to $15. All right, strawberries cost $1.25, so that's going to be my X. And cherries cost $2.40, so that's going to be my Y. So write and graph an inequality that shows the different amounts of each you can buy. So if strawberries is my X, that's going to be 1.25X plus my 2.40Y. So now I have my inequality here. This is in standard form. So whenever you have a word problem that's in standard form, instead of transforming it into y equals mx plus b, which we could do, but your slope might be something weird, I would find your if in standard form, find the x and y intercepts. Because then we know those are easy points to plot, connect the line, we're good. So if I'm finding my x-intercept, I'm going to substitute in 0 for y. So that's going to be 1.25x plus 2.40 times 0, which is less than or equal to 15. So I'll get 1.25x is less than or equal to 15. Divide by 1.25. And what is 15 divided by 1.25? $12. I'm going to do the same thing, but finding my y-intercept now. So I'm going to do 1.25 times 0 for my x, and 2.4 is less y, which is less than or equal to 15. So 2.40y is less than or equal to 15. Divide by 2.40. And y is less than or equal to 6.25. All right. So am I going to have any negative values? Am I going to have negative amount of strawberries or negative amount of cherries? No, because I just went buying you, it'd be 0. And that's what we just found is our zeros. So I'm just going to have my positive numbers, and at 12 on my x-axis, I'm going to plot my point. And then at 6.25, which will be in between 6 and 7, but closer to 6, I'm going to plot my point. And then is this going to be a solid line or a dashed line? Solid, because it has the equal to. So I'm just going to connect my points. And then are we spending less than $15 or more than $15? Less than, so it's going to be shaded below. So that means I'm going to shade here, this whole area. So that means like I could buy 2 strawberries and 2 cherries because I can get any value. It doesn't say that I have to spend all $15. It just says I can. So I can get any value that's in here. I can get 1.5 pounds of strawberries and or whatever, 4.5 pounds of strawberries and 2 pounds of cherries. As long as it's inside that amount. That's all that matters.